Hello everyone, my name is Chung Chiteng and I'll be presenting about MapReduce architecture. MapReduce is a programming model and an associated implementation for processing and generating large datasets with a parallel distributed algorithm on a cluster. To put it simply, it is a framework for writing applications that process large amounts of data. MapReduce also serves as the original framework for writing applications that processes large amounts of structured and unstructured data stored in the Hadoop distributed file system, or the HDFS. Now, the question is, how does MapReduce work? A MapReduce job splits a large data set into independent chunks and organizes them into key value pairs for parallel processing. This parallel processing improves the speed and reliability of the cluster, returning solutions more quickly and with greater reliability. There are two main functions involved in MapReduce, which are the start, map, or map and reduce function. The start function divides the input into ranges by the input format and creates a map task for each range in the input. The drop tracker distributes those tasks to the worker nodes. The output of each map task is partitioned into a group of key value pairs for each reduce. The reduce function then collects the various results and combines them to answer the larger problem that the master node needs to solve. Each reduce pulls the relevant partition from the machines where the maps executed, then writes its output back into the HDFS. Thus, the reduce is able to collect the data from all of the maps for the keys and combine them to solve the problem. Why use MapReduce? In a real-life environment, a method is needed to scale large data processing applications. The proper way to handle it is to divide the data and process on many nodes. As such, each application has to handle communication between nodes, division, and scheduling for, work, fault tolerance, monitoring, and reporting. MapReduce is capable to handle and hides all these issues and provides a clean abstraction for programmer. The advantage of MapReduce are locality. Job tracker divides tasks based on location of data. It tries to schedule the map task on same machine that has the physical data. Parallelism. Map tasks are run in parallel, working different input data splits. This ensures all tasks are handled on different intermediate keys. Fault tolerance. Failures are handled by re-execution. If a task tracker node fails, then all tasks scheduled on it are re-executed on another node. The disadvantages of MapReduce. Real-time processing. MapReduce needs time to process all the data. Therefore, real-time processing is not ideal as it takes time. Process isolation. All jobs are run in isolation separated from each other. This prevents any processes from communicating with each other. MapReduce is not suitable to handle streaming data. It is only best suited to batch process huge amounts of data that are available locally. Examples of MapReduce implementation. MongoDB or Mongo database. MongoDB is a or cross-platform document-oriented database. It is classified as a NoSQL database. It is first developed by the software company MongoDB Incorporation in October 2007 as a planned platform as a service product. The application of MapReduce in MongoDB is as follows. MongoDB applies a map phase to each input document. The map function emits key value pairs. For those keys that have multiple values, MongoDB applies a reduce phase, which collects and condenses the aggregated data. MongoDB then stores the result in a collection. Optionally, the output of the reduce function may pass through a finalize function to further condense or process the results of the aggregation. All MapReduce functions in MongoDB are JavaScript and run within the mongot process. MapReduce operations take the documents of a single collection as the input and can perform any arbitrary sorting and limiting before beginning the map stage. MapReduce can return the results of a MapReduce operation as a document or may write the results to the collections. The input and the output collections may be shared. The another examples of MapReduce is the geospatial query processing. With the technological advancement in location-based services, there is a huge surge in the amount of geospatial data. Geospatial data queries consume a lot of computational resources, and it is observed that their processing is intrinsically parallelizable. Google Maps uses MapReduce to solve problems like given an intersection, find all routes connected to it, rendering of the tiles in the map, finding the nearest feature to a given address or current location. In conclusion, MapReduce is generally a very good architecture as it greatly simplifies writing large-scale data distributed applications. Applications can be built to handle big data sets, which is one of the main requirements of software applications nowadays. Although the uneven implementation techniques of MapReduce, for example, Apache Spark, it is still a very reliable programming model and framework. Thank you for listening.